Hi, myself M. Junita, Assistant Professor, Department of Computers, KSS Kaustubh College. In this video, we can see about addressing modes. There are several types of addressing modes in computer organization. We can see one by one. First is immediate addressing mode. Second one is direct addressing mode. Third is indirect addressing mode. Fourth one is register addressing mode. Fifth is register indirect addressing mode. Sixth is displacement, that is indexed addressing mode. Seventh is stack addressing mode. Let's see one by one. Number one is immediate addressing mode. In immediate addressing mode, operand is the part of instruction. The operand is equal to address field. Example, add 5. Add 5 to the content of the accumulator. 5 is the operand. 5 is the operand which is in the instruction itself. No memory reference to fetch data. Fast and limited range. You can see the diagram of immediate addressing mode. There is operand is in the instruction itself, so no need of reference. Second, direct addressing mode. In direct addressing mode, address field contain address of operand. Effective address EA is equal to address field, that is A. Example, add A. Add content of cell A in accumulator. Look in memory at the address A of operand. Single memory reference to access data. No additional calculation to work but effective address. Limited address space. You saw the direct addressing modes diagram. The address is refer the memory address for operand. Third, we can see indirect addressing mode. In indirect addressing mode, memory cells points by address field contain the address of the operand. EA is equal to A. That is, effective address is equal to look in A. Find the address A and look there for operand. Example, add A. Add content of cell pointed to by content of A to accumulator. For indirect addressing mode, large address space needed. 2 power n, where n is equal to word length, may be nested, multi-level or cascaded. We need multiple access to find the operand, hence it is very slow. This is diagram for indirect addressing mode. Let's see, the address is referring the memory location. From this memory location, the operand is pointed out. So there is a multiple memory access is needed for find the operand in this indirect addressing mode. Fourth one is register addressing mode. In register addressing mode, the operand is held in register named in address field. That is, EA is equal to R. R is the register name. Limited number of register, so very small address field needed. Shortest instruction, fastest instruction to fetch. For register addressing, no memory access is needed. Very fast execution, very limited address space. Multiple register helps performance. Requires good assembly programming or compiler writing for this. Here is the register addressing diagram. You can see the instruction itself have the register name for the operand. Fifth one is register indirect addressing mode. In register indirect addressing mode, the content is from indirect addressing. EA is equal to register of, that is, operand is in the memory cell pointed to by the content of register R. Largest address space is needed. One few memory access, then the indirect addressing. This is the diagram for register indirect addressing mode. Here you can see in the instruction we have register address. Register have the memory address of the operand which have the value. Sixth one is displacement addressing mode. In displacement addressing mode, effective address is equal to A plus R, where address field hold two values. A is the basic value, R is the register that hold the displacement, or vice versa. Here you can see the displacement addressing mode diagram. In the instruction we have three parts: opcode, register and address. Register which holds the address of the operand, and the address field holds the memory address of the operand. By adding these two, you can have the effective address. We can see relative addressing, a version of displacement addressing. R is equal to program counter, that is PC. EA is calculated from address plus PC, content of PC, that is getting operand from A, cells from current location pointed to by PC. So content from locality of reference and cache usage. Next we can see index addressing. This is a version of displacement addressing. In this mode, the content of an index register is added to the address part of the instruction to obtain the effective address. The base register is a special CPU register that contains an index value. The address field of the instruction defines the beginning address of data are in the memory. Each operand in array is started in memory relevant to the beginning address. The distance between the beginning address and the address of the operand is the index value stored in the register. That is, EA is equal to A plus R. Next is basic register addressing. This is also a version of displacement addressing. In this mode, the content of basic register is added to the address part of the instruction to obtain the effective address. This mode is similar to the index addressing mode, except that the register is now called the base register instead of an index register. The difference between this mode is in the way they are used rather than in the way they are computed. An index register is assumed to hold an index number that is relative to the address part. The base register is assumed to hold the base address, and the address field of the instruction give a displacement relevant to its base address. Seventh is stack addressing mode. In stack addressing mode, the operand is contained at the top of the stack. Example, add. Simply we give add. This instruction simply pops out two symbols contained at the top of the stack. The addition of these two operands is performed. The result so obtained after addition is passed again to the top of the stack. This is stack addressing mode. Thanks for watching.